name is Scott Wankel. I'm an assistant scientist at the Woods Hole Oceanographic Institution here in Woods Hole, Massachusetts. My research focuses primarily on understanding nitrogen cycling in the environment. Nitrogen is a critical element, critical nutrient for all living things, all life. And so understanding how it cycles in the environment is useful for us as humans and for understanding how ecosystems work and function. I have a team here at WHOI that includes a postdoc scholar, a postdoc researcher named Cary Buchwald. And together with my whole group here, we focus a lot on using stable isotopes as tools for understanding how nitrogen is cycled in a wide variety of environments.
My name is Cary Buchwald. I'm a postdoc at Woods Hole Oceanographic Institution. I think most basically, I'm a chemical oceanographer. So nitrogen is one of the major nutrients that is important for all life, for us and all life in the ocean, specifically because we study oceanography. And then when we talk about the nitrogen cycle, so nitrogen is a unique element in that it comes in many different compounds. In the environment, there's gaseous forms, nitrogen gas, nitrous oxide, which is a major greenhouse gas, and then it also comes in the nutrient forms, nitrate, nitrite, ammonium, and those are what we all need to grow and live. And so we call it the nitrogen cycle because there's actually, the transformations between those different compounds are what we call the cycle, and those are facilitated by microbes. Part of the class is understanding, where nitrogen is entering, or when we've been putting nitrogen into these estuaries through wastewater runoff and agricultural growth and fertilization, and understanding how that nitrogen is actually removed, because nitrogen is good because you need it, but when it's in excess, it actually can be really bad for the environment, and it causes overgrowth of algae and depletion of oxygen in the environment. And when there's no oxygen there, the bigger organisms like fish and shellfish and the things that we like to eat out of the ocean can't grow. And so these denitrifiers and different microbes are actually really important for keeping the environment in a healthy way so that larger organisms can live there.
One of the more compelling drivers for our research in this lab actually has to do with understanding how some of these nitrogen cycling processes may act or may behave or may respond to different kinds of environmental perturbances in the production of a powerful greenhouse gas, nitrous oxide, N2O, commonly known as laughing gas. This is a very powerful greenhouse gas that acts to, in part, to warm the atmosphere, the Earth's atmosphere. So there are a lot of different biological processes that happen, so microbial processes that are catalyzed by fungi, by bacteria, that actually result in the production of nitrous oxide. There are also, we're discovering a lot of just pure chemical reactions that happen naturally in the environment that also produce this nitrous oxide. And part of the research questions that we're trying to understand here in this lab actually involve using these natural isotopes as a way to better understand the relative importance of some of these processes for that production of that gas. How do we know that these microbes are actually doing this? Well, that really involves performing experiments, growing microbes in the lab, seeing that they can catalyze these reactions. And then we have different kinds of tools to go out in the environment and quantify how many microbes are there, how many of these microbes actually have the enzymes that catalyze these processes, and how much of those enzymes are being expressed in the environment.
So I think part of what researchers are trying to understand is how to create these environments and where denitrifiers will thrive, or try to figure out solutions for removing the nitrogen from the system. And a couple of those, one of the things that we go through in this class that is about using actually aquaculture to promote the growth of these types of denitrifiers, or even putting things into the environment that promote the growth of denitrifiers, and that will in turn remove the nitrogen. So just really understanding how these microbes grow, where they want to exist, and how we can sort of use engineering solutions to fix that in the environment as well.